Hello everyone. In this class we shall learn about the associative law or associativity property in Boolean algebra, which is basically this: a plus b plus c. Here b plus c is in a parenthesis. This is equal to a plus b plus c. Here b plus c are in the parenthesis, and here we have taken a with b in a parenthesis and c outside. A plus b plus c, this is equal to a plus b plus c. This is the associativity property for addition. Similarly, for the associativity property for multiplication is this: a into b into c. Here b and c are in a parenthesis, and this is equal to a into b into c. Here we have taken a and b in a parenthesis and c outside. Observe that this is a plus and this is multiplication. In place of addition of the first property, that means the associativity property for addition, in this first property, if we replace this addition by the binary operation multiplication, then the second one we shall have. So the second one, that means the associativity property for multiplication is the dual of the associativity property of addition. So if we can prove any one of these two, then the remaining proposition will hold good due to the duality principle of a Boolean algebra. So let us now see the first one. Let us now see the proof of the first one. That means the associativity property of addition. Here we have multiplied this left side element, that means a plus b plus c by a plus b plus c into a. We also know that the multiplication is commutative. So this is equal to, the multiplication being commutative, this left hand side, this is equal to a into a plus b plus c. Now we are using the distributive property of multiplication over addition. So this is equal to a into a. Here we have written a into a plus a into b plus c. This is a into b plus c. And this is equal to a into a. This is equal to a. From the idempotent property we can write this, and the remaining part we have written a into b plus c. Same. So now from the distributive property of addition, of multiplication over addition, from this we can write a into b plus a into c. We have written here that very. So this is equal to a plus a into b plus a into c. Now we are taking this element a plus b plus c, and similarly we are multiplying with this element by a plus b into a plus b plus c into a. And also from the commutativity property we can write this is equal to a into A plus B plus C. Here also we are using the distributive property of multiplication over addition. So this is equal to A into A plus B, A into A plus B plus A into C, A into C. This is equal to A into A plus B plus A into C. A into A plus B plus A into C. And here we are using again the distributive property of multiplication over addition. So this line is equal to A into A into A plus A into B, this is, plus A into C. And we also know that A into A from the idempotent property in Boolean algebra, this is equal to A. So actually this equal to A plus A into B plus A into C, which is equal to this line, and we have this line from this. So we can write A plus B plus C into A. This is equal to A plus B plus C into A, and we have written that A plus B plus C into A, this equal to A plus B plus C into A. We have written A plus B plus C into A. This is equal to A plus B plus C into A. This is number one relation. Number two. As here we have multiplied this left hand side once by A and this right hand side once by A. Here we are multiplying this left hand side member by A complement. This is A plus B plus C into A complement. Similarly, from the commutativity property of multiplication, we can write this is equal to A complement into A plus B plus C. And we are now using the distributive property of multiplication over addition. So this is equal to A complement into A plus A complement into B plus C. A complement into B plus C. As the multiplication is a commutative, A complement into A, this is equal to A into A complement, and from the distributive property of multiplication over addition, we can write from this line A complement into B plus A complement into C, this is. And also from the complementation property in Boolean algebra, we know A into A complement is equal to 0. So in place of A into A complement, here we have written 0, and the remaining two are remain same, A complement into B plus A complement into C. So this is equal to, and also 0 being the additive identity element, this is equal to A complement into B plus A complement into C.